Integral calculus. It is another branch of calculus known universally as the reverse of differential calculus. If you can remember your previous studies, differential calculus focuses on finding a derivative, which represents the rate of change of a quantity with respect to another. On the other hand, integral calculus involves finding the definite integral or the area beneath the graph over a specified interval and the indefinite integral or the antiderivative.
However, at this point, we will be only focusing on indefinite integrals and its basic rules, as its concept, primarily the antiderivative, are the prerequisites in finding the area below the curve.
Now, let's take a look at the general form of an indefinite integral. The integral of f of x with respect to x is equal to capital F of x plus c. The summa symbol you see at the left represents the process of integration. This is the integral symbol. The f of x is the function you are integrating, called the integrand. It is a derivative of capital F of x, meaning f of x is equal to capital F prime of x. The dx indicates the variable of integration, which tells that we are integrating with respect to x. The capital F of x represents the antiderivative of f of x, which when differentiated back will give you f of x, hence proving capital F prime of x is equal to f of x. The c is the arbitrary constant.
Now, let us move on to the basic rules of integration.
The first basic rule is the constant rule, which states that the indefinite integral of constant k with respect to x is equal to the constant k times the variable plus the arbitrary constant. Suppose you want to find the indefinite integral of 4 with respect to x. In this example, your constant k is 4. The constant rule states that the indefinite integral of constant k with respect to x is equal to the constant k times the variable plus c. Following the constant rule, the integral of 4 with respect to x is equal to 4x plus c. Now, let us say you want to find the integral of dx. What will you do? Remember that integrating dx is just the same as integrating 1 with respect to x. Thus, it can be interpreted as the integral of dx is equal to the integral of 1 with respect to x. Okay, so you see that your constant k in this situation is 1. Now, following the constant rule will give you an antiderivative of x plus c, and that is the final answer. The second basic rule is the power rule, which states that the indefinite integral of a function of the form x raised to n, where n is any real number unequal to negative 1, is equal to x raised to n plus 1 over n plus 1 plus c. Let's say you want to find the integral of 4x raised to 3 with respect to x. In this example, your n is 3 and your constant multiplier is 4. Before you can integrate, you can separate the constant multiplier from the integral of x raised to 3. Following the power rule, x raised to 3 would become x raised to 3 plus 1 over 3 plus 1, which would result to x raised to 4 over 4. Now, you can multiply the constant multiplier back, which would result to 4x raised to 4 over 4. And finally, simplifying, we would get an antiderivative of x raised to 4 plus c. Now, what if the given example is the integral of x with respect to x? Feel free to pause the video and try it yourself. Remember that x is just equal to x raised to 1. With that, applying the power rule, x will become x raised to 1 plus 1 over 1 plus 1, which will give us an antiderivative of x raised to 2 over 2. And that will be the final answer. The third basic rule is the sum rule, which states that the indefinite integral of the sum of functions is equal to the sum of the integral of each function. For instance, you want to find the integral of 2x plus 4 with respect to x. Applying the sum rule, separate the integral into the integral of 2x dx plus the integral of 4 dx before you can integrate them. For instance, you want to find the integral of 2x plus 4 with respect to x. Applying the sum rule, separate the integral into the integral of 2x dx plus the integral of 4 dx before you can integrate them. Now, to integrate 2x with respect to x, we need to follow the power rule. 2x will become 2x raised to 1 plus 1 over 1 plus 1. and then simplifying it will give us x raised to 2. Next, integrating 4 with respect to x will give us 4x according to the constant rule. Combine the results, we will get an antiderivative of x raised to 2 plus 4x plus c.
And finally, the fourth rule is the constant multiple rule, which states that the indefinite integral of a constant k multiplied to a function is equal to the constant k multiplied to the indefinite integral of a function. In other words, the constant k can be factored out from the integral. For example, you want to integrate 6x with respect to x. Before you can integrate, you can separate the constant multiplier 6 from the integral of x dx in application of the constant multiple rule. Afterwards, you can now integrate x with respect to x.
Following the power rule, x will become x raised to 1 plus 1 over 1 plus 1, which would give us an antiderivative of x raised to 2 over 2 plus c. And then, multiply the constant multiplier, 6, back to our answer, and simplify 6 and 2, which will give us an antiderivative of 3x raised to 2 plus c.
Now you know the basic rules of integration. Take note that even though it is still basic, you still need to know and learn about it, as they are the prerequisites for the next rules to come. Also, as a final word, never forget the arbitrary constant when integrating. Thanks for watching, and I'll see you next time.